Good afternoon, everyone. This is Christy Sullivan. I'm with the Secretary of the American Society for Cellular and Computational Toxicology. I'm excited to have a webinar for you today on the integrated chemical environment given by Dr. Shannon Bell. Before we get started, I just wanted to briefly tell you about the Society and our annual meeting. We are a society focused on cellular and computational toxicology methods. We've been around for about 8 years, and we host webinars. We provide travel grants to early career scientists to relevant meetings, including our own. And of course, we have an annual meeting. And the next meeting is coming up really soon, September 11th. There are still places left, so feel free to come to the website and register if you like. The website's there at the bottom of your screen, ascctalks.org/annual meeting. We pack a lot into one day. We have some really exciting invited speakers focusing on different aspects of implementing predictive toxicology approaches. And we have talks chosen from submitted abstracts, as well as a big poster session. We also have some an evening reception the night before with some mentoring activities. We have a panel discussion at the end of the day. And we have a social reception, and we give some awards. And so I would invite you to go to our website and see the full program and learn a little bit more about the meeting. So today, just a bit of housekeeping first. This webinar is recorded. Members can access a recording of this webinar and all past webinars on our webinar archive. So if you're interested in that, I invite you to become a member. And everyone is muted. If you have a question for the presenter, please use the question module and we'll address your questions after the presentation. So let me go ahead and give you the keys. Dr. Bell. Dr. Bell, a computational toxicologist who leads the CompTox and data science group at Integrated Laboratory Systems. And as I said, she's going to be talking, give some information and a demonstration of a publicly available web database called the Integrated Chemical Environment. So when you're ready, feel free to take it away.
Yeah, hi everybody. And thank you, Christy, very much for the invite to present. So I work for ILS, and we support NICEDM, which is the National Toxicology Program Agency Center for the Evaluation of Alternative Toxicological Methods. So the group is organized under NTP, so it's part of NIHS, and ILS. We provide technical support for NICEDM under a contract. And so here's a nice picture of the group. It's a little bit dated, but there's 3 federal employees. So Dr. Mall, Dr. Casey, and Dr. Kleinstra, and they provide the vision, and we help provide the brute force to get it done. I encourage you guys to go to the website, and these slides will be made available. So there's going to be a few URLs poking up here or there, but I encourage you to go to the website, and you can sign up for our NICEDM newsletter, and it'll keep you informed of different events that are happening that are relevant to alternative methods, which I think most of the folks on are involved in ASCCT would be interested in. So what exactly does NICEDM do? NICEDM has a couple different charges. One main one is to evaluate alternatives to animal use for chemical safety. So alternative methods, for those who aren't aware, are ones that really look at reducing, replacing, and refining existing animal methods. And so some of these may be computational models, some of these might be ex vivo or in vitro assays. We also conduct and publish on either data sets that use these new testing approaches or reviews of different materials available, and provide information to different test method developers, work with them for validation, regulators, and the regulated community. So as you can imagine, those two activities there do leave us with an awful lot of data. The other thing we do is we support the Interagency Coordinating Committee on the Validation of Alternative Methods, or ICAM. So that's a congressionally mandated authorization act. And the important thing here is there's a whole lot of different US federal agencies that either use animal methods or require some kind of animal-based test, or they do research using animals. And the idea is that we want to coordinate among them to really help institute the 3 R's, so reducing, refining, replacing animal tests, while ensuring human safety, human health safety, and environmental safety, and then the effectiveness of the product or the procedure that's going in. So we are moving towards new approaches to this safety testing because we recognize that humans are not simply bigger rats. We also recognize that you can't go ahead and do chemical safety testing and toxicity testing on endangered species, and that, you know, a rat or a fish can't be used for all the different animals that are out there. Animal testing is also really resource intensive in time, money, and is being phased out globally, not only because of the expense, but because there's a lot of ethical issues, and it's just not as informative for the reasons I mentioned earlier. You know, humans aren't big rats. The regulatory acceptance, though, of these alternative methods has been met with some resistance, understandably, because a lot of the folks who are then coming out to evaluate these methods, they're not used to seeing this type of data. And so they really need to have some help in understanding the differences of these approaches, what the limitations are. They need some context for the assays. When you used to have a simple, you know, did the animals die or are they alive type of assay, and now you're faced with a whole bunch of different assays that may give you readouts on very specific molecular processes. How do you start relating that information together? And then when we have these predictions, especially coming from these QSAR models, how much confidence can I have in them? Does this work for my chemical space? And so these are a whole bunch of really complex questions that need to be addressed so that we can move forward. One thing that they are pointing to is the fact that we really want data, and we need to have data-driven decision-making as a central focus in everything that we do. These non-animal methods have high data requirements, not only to reassure the people who are evaluating them, but they have high data requirements to even develop them. If you think about the development of a computational model, most of these models require some kind of training and evaluation data set, which needs to be quite large. When you're thinking about developing a new benchtop assay, well, you need some kind of gold standard data to compare your results to. You need to know what types of chemicals you should be running through your assay, and then you need to figure out how to integrate all the data that's coming out of your assay and compare it back to the current gold standard. When we think about these data-driven decision makings and data-to-decision approaches, it all comes down to, well, how can other people look at the data that you used and start making some decisions as to whether or not they agree with your final result? And part of that is making data free and fair. So FAIR is a data standard that stands for findable, accessible, interoperable, and reusable. I'm not going to go into too much details about it, except for to say this is about making data accessible to the appropriate people at the appropriate times and in the appropriate format. So it doesn't mean that data is out there forever and for everyone. It means that the right people are getting the data that they need in a format that is appropriate for their use, and they have the information that they need to then use that data. Because of this, and because of all the data that NICEDM ends up developing through its efforts, we needed a place to share this data with other folks, our stakeholders. And we created the Integrated Chemical Environment, or ICE, to do that. So we wanted a resource that would be the central access point for any stakeholders in ICEDM. And so this includes risk assessors, your chemical producers, and also your method developers. And one key point in looking at that is that we needed something that was going to be really user-friendly, easy to use, and would provide people with confidence that they needed, that they were getting some high quality data, as well as the reference chemical lists. So what this means for me is that instead of getting multiple requests for a reference chemical list or some data, I can now direct people to a resource where they can help themselves to the data that they want. And then we can follow up with them to make sure that it's still meeting their needs. We also added easy to use tools that help support the prioritization, data exploration, and hypothesis generating steps for those researchers out there. There's two key components right now. The data integrator, which was designed to be really easy to use and focuses in on those regulatory endpoints of interest. So while some resources may be very chemical centric and you're searching for a very targeted chemical and finding the data on that particular chemical, or it might be a gene focused type one or protein focused type of a system, or pathway focused type system, we are focused on regulatory endpoints of interest, because NICEDM is really focused on the regulatory needs and the regulatory requirements of these different assays. We also have workflows, which is relatively new, and we're bringing them out as web-based. And this is so that it makes it easier for people to use and really easy to explore. With a lot of these new methods that are coming about, we believe that one barrier to their adoption is that folks just, they can't touch it. A computer model can be very difficult for someone who isn't a coder, doesn't program, and has not a mathematician. So understanding how do these models work, what are the differences, I want to play with it. To address those needs, we really went to web-based tools. The URL is at the bottom, and of course the slides will be made available so you can get on there and play around yourself. So what all goes into ICE? We have a couple different things. Of course, the data and the chemical lists from our validation studies is one of, I think, the key and important resources that we had. So this data used to be available in PDFs and in some Excel sheets scattered about the NICEDM website, and in accordance with the FAIR data principles, it is now in a downloadable, easy to download format in a database that will, I think, make it much more accessible to a variety of people. We also have published data, so this is data that's not only coming from NICEDM authored publications, but also publications from other collaborators and stakeholders that have met our review process. So do we have high confidence in the data that comes in? How have we done some curation on it? And the type of curation that we do, and this applies to all of them, is checking for consistency between the chemical name and the chemical identifier, looking for units so that we don't have the 2,000 kilogram rat. Those types of things that we hope will ease the burden on those who are using the data, that they don't have to go through extensive cleanup. We also have data that comes from databases. So we do have some data that comes from partners at EPA, as well as other resources. We are forming relationships with other databases at NIEHS so that it'll be more seamless transition between the data that's in ICE and the data that's in those resources. We also have computational models in two formats. On one hand, you'll get the data, the predictions that are coming out of these computational models. And I'll go into a little bit more detail on one set of data that I believe will be of great interest to this community. And then we also have workflows, so computational models that you'll be able to run on the ICE interface, and I'll demo one of those in a little bit. So as far as data that's currently in ICE, it's a little bit limited, and so we have the data that's shown here, and there's more that gets added on it as we receive it. So one thing that I'll be asking for in a little bit is doing a call for data. As you can see here, I don't have inhalation data aside from in our formulation studies. And our formulation studies, it is the 6-pack. So that's acute oral dermal inhalation, skin sensitization, skin irritation, and eye irritation data on formulations. And this data was obtained with a collaboration through EPA. And so there's no CBI data here, but you'll be able to see active ingredients for a list of formulations, the percent active ingredient, and then the toxicity, the EPA and GHS labeling values. So you can see that we have an awful lot of data, and I'll be talking about the CHTS and the OPERA predictions next to go into that. So the OPERA predictions come from the OPERA models, and so this is a collection of quantitative structure activity relationship, so QSAR, type models that are based upon a chemical structure that was developed by Kamel Mansouri, who's on the ILS team. This is work he was doing while he was at EPA, and he's been extending it while he's here for some additional endpoints. The key thing to note here is that when Kamel does his modeling, he is doing it based upon the OECD principles for QSAR modeling. And so this, we hope, is going to give people good confidence in using these predictions, that they were done to some standards, and that you'll be able to see how those were developed. Right now in ICE, we have a few different endpoints, and there's more that are going to be added. So things like log P and vapor pressure, Henry's law constant. I think the next ones that are going to be coming online probably in the spring are going to be of high interest. That there's a PKA predictive model that he's been working on, and then there's a model to predict acute oral toxicity that came out of a collaborative modeling effort that happened in the spring. Excuse me. The CHTS data is stands for curated high throughput screening. I think, excuse me, sorry guys. I think most of us are familiar with the ToxCast and Tox21 data. And so this builds upon that. One thing that was important to us with ICE is that we had data that people felt really confident in using. And because of that, we decided we needed to do a little bit of a level of curation and limit some of the data that was coming in. And so we did a couple filtering steps, and this was work that was led by Dr. Karmaus, and her knowledge of the assays has really been helpful in removing some of the more questionable calls and really getting a better feel for the data that's there to increase the confidence. So anything that had any chemical where we had concerns about the chemical being assayed actually being what at the concentration that it was stated and at the format, anything that had a caution flag was removed, so it no longer showed up as a hit. And so you'll see when you go to ICE, you'll see QC omit flags raised, different other assays as well. And any time where you had a hit that was outside of the maximum testing concentration was another one. So to avoid over-interpreting and giving you a false sense of what the AC50, potentially a false sense of what the AC50 would be. So here's a couple of examples of omitted calls, ones that with using the TCPL pipeline would be active, but once you integrate the flags that are included in the pipeline, you can remove. And so this one right here, only the lowest concentration really exceeded the cutoff, and this is a gain loss type model. And so there's a couple others here, and I'm happy to talk to people a little bit more about how we've implemented this. And again, the whole point of this step was to give people a little more confidence in insurances is when they're using it, especially since with ICE, you're not getting all the detailed information that you would if you went and took the data from the TCPL package. So here's my call for data. We would love to speak with you if you have a lot of data that you are willing to share, especially if it's guideline or guideline-like in vivo data. I'm especially in need of inhalation toxicity data. That is an active area of interest, and getting more data will better enable us to evaluate the performance of the current method for getting endpoints and help inform potentially new methods that are being developed in vitro data. Specifically, I'd like to get some eye and some more eye and skin endpoints. When it comes to formatting, because that's always the questions that I get asked, we do have some templates for the types of endpoints that we're interested in, but when it comes down to it, I'm really looking for some kind of chemical identifier at the structure level, ideally, but Cas is fine. The endpoint that you're measuring the response, and then any metadata that's appropriate for that particular assay. So coming up next in the September, which I'm realizing is a week away, and so this will likely be right around ASCCT annual meeting, you'll have on the public site the IVIVE workflow, and this allows you to use ICE, an ICE query, and endpoints in vitro assays from the CHTS collection and be able to estimate an internal dose. It's a simple one compartment model. Opera model predictions for PhysChem in some of the modeling parameters, and then improved CHTS. So we had limited filters in the data that's currently out there. It just filtered for chemical QC. These improved filters we're hoping will decrease the number of poor confidence values. And so it's not that the values, the hits, are necessarily wrong. It's just that our confidence in them is really low. And again, the purpose of ICE is to provide people with high confidence data. So coming up next, we will be launching ICE 2.0 in this spring ahead of SOT. So we will be allowing users to import their data, which will be great given the workflow function. And so this means that for accessing the IVIV tools and some of the other tools that we'll have available with that release, you'll be able to import your own chemical list. We'll be doing predictions from that data. So the Opera model predictions, you'll be able to run using the ICE interface and provide those in bulk, which I think will be very advantageous because most people who use ICE really aren't going after a single chemical at the time type of investigations like they would be with some other platforms, but really have a list of chemicals that they're interested in, and providing predictions in bulk is going to be, I think, a good feature for the community. We'll be expanding the workflows. So like I said, right now we have a one compartment IVIV model. We'll be adding a 3-compartment PBPK model, generalized, and that's going to include metabolism for glucuronidation and sulfation. So you'll be able to get a better sense of or a more detailed view of your IVIVE needs. I'm really excited about that generalized PBPK model. It will be liver, kidney, and gut. Chemical characterization is going to be coming online, which will allow you to put in your list of chemicals, get a breakdown of the different PhysChem properties, and then as well as get a sense of how these chemicals are typically used. And that will be using some of the EPA resources, especially their consumer product use database. So now it's time for the live demo. So I'll switch back to a couple slides of acknowledgements once I'm done here. So hopefully everyone can see the screen. This is the public ICE webpage. If you would like to go to run a search, you go over to the integrator tab. There's a couple key features here that I want to walk through. The first here is where you select your chemicals. We have a lot of different reference chemical lists in ICE. And by clicking on this little icon here, you can download them. I have one already downloaded because you never know how long it's going to take when you're running a WebEx. And so this is what it looks like. You can download the Excel format or a tab delimited format. You will get down a nice, easy to read page that gives you the different endpoints of what was used in that particular validation. So for this, in this case, it was the 2009 LLNA exam study. And you'll be able to provide, if you go into the data sets, which is right here, you'll get a link to the reference, so you can go get more details about that particular one. The other thing I want to point out is how we have the assay selection organized. So the cool thing about this is that we have it organized by your selected or your targeted endpoint of interest. And so you can go ahead and select based upon your endpoint. You can also select if you want certain activities. So if you want something that is active for call data and skin sensitization, or inactive or other. So I'm going to go ahead and show one more thing on this list. So if anybody has used the ToxCast Tox21 data, you understand that there are a ridiculous number of assays. So we have grouped these assays, and you can find details in the About Datasets page. We've grouped all the different ToxCast assays, or as many as we could, into appropriate classifications. So we will be updating this for the spring release to be more in line, because EPA has recently done a better job of annotating their assays, and so we will be using those in addition to some of the annotations to toxicity endpoints that Dr. Carmouse has been developing for ToxPy. And we'll be leveraging those, especially when it comes to developmental tox endpoints, which I think will be of interest to a lot of our users. So this allows you to select a group of assays without having to select all 10,000 assays. When I want to run a query, I'm going to go and either enter in my own chemicals or select a few different chemical lists. Select a few here. And so it indicates here that I've selected some reference chemical lists. I can also add in my own CAS-RNs to this line if I'd like. If I don't select anything, then pretty much everything will be selected. And I can also toggle between union and intersection. You generally are going to want union. Now, after the query has been run, I get this results table. This lets me know what reference list I have selected, and if I've selected different assay targets, it will show those up here too. I also can see the total number of chemicals that was returned, and I can do some filtering on them. This table here is a summary table. We call it the wide view table. And so this is going to give you an idea of what types of results were returned. So here, for acute oral toxicity, the median value was 23. There were 2 samples, so one sample was 18 and the other sample, or the other endpoint, read 28.27. So this is kind of nice to get a quick overview of your data. But what's also nice are these charts. So this here gives you a breakdown of all the different endpoints at the top level. So clearly all the in silico data coming from these in silico model predictions, such as chem properties, etc., are going to be in silico type, and the CHTS is all in vitro data. But for some of the others, it's really nice to be able to see where your breakdown is. And so, for example, with skin sensitization, we've got 9 in vivo chemicals, and we've got 24 that have both in vivo and in vitro data. And if I want to get that chemical list, I can click on it and it pops up. And so now I can take this chemical list and go on and do other things with it. What's also useful is, sorry if I'm going too fast to make you sick, is that you can get this breakdown. And so for some of them, it's more useful than others. So for the irritant data, we have 169 compounds that have an EPA classification for I, and then it shows the breakdown of the different decision criteria there. Now, I can also download this data. And if I go here, I can do some filtering on it first to look at all the different endpoints and assays that I want. So I can go ahead and filter here on a couple of the ToxCast or Tox21 assays. And that will update my data table here so I can see. So this is only updating it in this particular table before I can then download the data that's presented here. If I want to download it though, the full data, it would be here. Summary data is this wide table you see behind the pop-up box. The summary data plus the individual CHTS experiments is what most people are going to want. Unfortunately, this doesn't play as nice with Excel because it gets to be quite massive. And so that will be available in tab delimited format. And then you can also download the long view. When we're talking about the long view, this has one endpoint or one result per line. And I really suggest going this route if you're going to take any kind of computational approach to the data. This is the best format for that, because it allows you to see an unsummarized view of the data, so you have each individual endpoint coming out. So I want to kick this over to formulations. So I'm going to go press this button, and it's going to send my query over to the formulations page. This warning pops up because our formulation data is actually pretty limited right now, and so there's a whole bunch of casts that weren't found. So I'm going to ignore that for now and go and look at my outcome, or my output. So in this first column, it shows you the formulation ID, and this is basically the formulation name. Then we have a column with active ingredients. Right now it's blank. If I go ahead and expand any one of these formulations on the side, then I can see the individual active ingredients, their CAS-RNs, and then the percent concentration of that active ingredient. As we go along to the sides, for the formulation, you'll be able to see what the score is. And so the different EPA and GHS categories, along with any value if those are present. So, greater than 2,000 or within a range. And again, this was data that was obtained in collaboration with EPA of pesticides, and we hope that it'll be useful for folks looking at some of the differences and the different components of that formulation. And we hope to expand this and provide better integration between this and the data that comes in the integrator, so that folks can do a few more meaningful analyses and investigations on that. And again, once you've gone here, you can go ahead and filter. So I want to filter on some active ingredients. There's a few active ingredients that I am really interested in. And then I can go ahead and filter down my table and then query the integrator for just those particular active ingredients I'm interested in. And it will, whoops, and it's going to return the same results using just those active ingredients. So it's a nice way of doing some exploration and then pulling out some more detailed data. When it comes to the workflows, this will be coming live in a week or so. The one that I'm going to show right now is the IVIV workflow. So this was a requested item by our stakeholders, and so this is one where it was specifically added due to stakeholder requests, and it will continually be developed and upgraded to help make sure we are meeting the stakeholder needs. So the first thing you want to do is identify the type of data that you're using your input. And so what IVIV does is it takes an in vitro value, so your ACC or AC50, and then figures out the estimated administered dose for that you would expect to see the similar in vivo effect. So if we choose our value here, we can then go and select what assays we're interested in. And so again, these are the same that were on the integrator search page. And then I can also search the reference chemical list. And I'm going to choose a whole bunch of chemicals here. And then run my workflow. So while it's running my workflow, if you have a really big search, it is going to take a little bit of time. The results of the workflow will appear down below, and there's a couple things I want to show you. The number of rows indicate the number of chemical assay unique pairs, right? You can still filter on your chemical and cast like you could before. We have all the values that were used for the calculation, so you'll have your fraction unbound and your clearance rates. You can filter on assays if you're interested in one particular assay, and then we have the EAD at the 50th and 95th percentile. And so these are estimated based upon Monte Carlo simulations of a population distribution. For your more protective, so health protective, cautious limit, you'd want to use the 95th percentile, and that's the default that is shown here. So the top plot shows your box and whiskers plot for all the different CAS-RNs, and it's pretty hard to read. So we can go ahead and we can zoom in on one part of it to really expand see on the side, we see the distribution of each individual assay point right here, and then we can see the overall performance. And so you have your max, your min, and all the different statistics. So what's nice about this is if you want to take a picture of it to download, you have all those options over here, and you can also click back to zoom back out. You can toggle between the 50th and 95th percentile, so you will see some differences in the points there. And then down below, we have the box and whisker for your AC50. So you can see actually how the assays perform. And, you know, this might be useful when you want to identify how different assays in conjunction with the filters are changing their performance. And again, you can download the table and do some filtering on it. So I'm going to switch back over, and I'm sure when questions come up, I'll need to go back to one of the two platforms. We do have a lot of really interesting things coming up, and we do want to make sure that this resource is really useful for our stakeholders. So please, check us out on the public site, which is listed below, or send us an email if you have any questions or you're having issues using it, or you have some ideas of things that would be really interested. You'd be really interested in seeing being developed. I want to give a big thank you to all the members of the team, and there's other people within NICEDM and outside that have also helped, but specifically a big shout out to Jason Phillips on the SciOM team, who is the lead on their side, who handles all the web development and tells me whenever I have a data set that is broken for the third time that I need to go back and fix. On the ILS team, for the work that was shown here, I really want to do a shout out for Kamel. He's the one who develops the opera predictions. Agnes is my point person for helping with the CHTS data, and her and Patricia are helping me develop an ontology to really organize the data and the assays better so that it'll be more intuitive searching for those who are interested in finding a toxicity endpoint and don't want to have to go and click on 500,000 assays to figure out which ones are most relative to what they're after. Xiaoqing Chang has been developing the IVIVE workflow, and Ruhi Ra has been the one who's helped me take all of our workflows and start getting them into scripts that can then be run on the integrator. And Neil's work, he's developed a machine learning pipeline, which I think will be really fun for some of the regulators to start playing with some of these machine learning methods. And you may even be seeing this in 2 weeks. I couldn't show it to you today. But it should be kind of fun. Unfortunately, the ICE data are pretty limited, but you'll at least be able to get to play around with some of these different machine learning algorithms you may hear about and see what the difference is between them and how they perform. And then Farah and Kathy have been a really big help in making sure the website looks good and the content's there and providing some new ideas, especially with the 2.0 release. So with that, I'll take any questions that you guys may have.
Great. Thank you so much, Shannon. That was a great overview. We do have a couple of questions already. And again, if you have a question, please type it in the question box, and we'll get to it as soon as we can. So the first question is from Myung Yoon, and she's wondering if you can explain a bit more detail how you include glucuronidation and sulfation. And I think that's a couple of slides ago where you're talking about some of the new tools.
So
specifically, sorry, just follow up, would they be separated from hepatic Clint?
All these details. Let me so when you go here for the workflow, it'll be another selection as to whether or not you want these included, and I'm kind of thinking that I want them as being the default. And so those are separate predictive models, which will be developed with Kamel's help as we're working on getting some QSAR type models. So an individual will give their chemical list, and then there'll be a prediction that's run as to whether or not we expect a chemical to have glucuronidation, to undergo glucuronidation or sulfation. And so that's how that's being done, and then it'll be the the generalized model will just include that it's a separation. And for more detail on that, I'm going to have to tell them to send me an email, and I will put them in touch with Xiaoqing, who is the developer for that. Is there a next question?
I'm sorry, I was on mute. So we have another question from Ignacio Tripodi, and he's wondering, he first of all has a compliment, says this is an outstanding data aggregation effort, and think of a couple of applications for his research. He says, you mentioned there's also gene information here. Is there a way to look for relations between certain chemicals and their affected genes or regulatory proteins?
Hopefully that will be online in as part of when the ontology comes out fully in the spring. So when I mentioned the genes, a lot of databases are very gene-centric. With some of the data that we have from ToxCast and Tox21, EPA has made some associations to those genes using gene ontology, and so we'll be able to leverage those associations with what's out there already. And so you will have some of that. I have a workflow that's developed where it allowed users to go from ICE data to the AOP Explorer, so they would be able to then take the results from Aquaria and ICE, send them in and map them onto the AOPs that were available in AOP Explorer by the key event relationships. And so I'm thinking that may get to be where he's thinking. With that, you should also be able to map to Reactome and put them on a Reactome pathway if that's the kind of thing he's interested in. But I would like all that to be online and up for February. That's probably not going to be, all those details will probably not be on that February release, because that's asking quite a lot of the web team.
Okay, great. We have a question, what about general metabolism, for example, P450?
So those are included in the one compartment model. So general metabolism, so your general cytochrome P450 metabolism is included in the one compartment model by default. These will be additional components that would be added with the glucuronidation and sulfation. And those were specifically requested by partners to to add those features on.
Okay. One of your examples in the demo was a mixture. Are you able to see interactions of mixture components within ICE?
You can find some data on the individual mixture components. We don't have all of them, but we do have quite a few. And one of the things that is in the wish list is being able to take the data from the formulation type data and then overlay on what individual endpoint for the individual chemicals we have. That way folks can see, okay, well, here's my mixture 1, here's my mixture 2, these are the chemicals they have in common. This is the profile, response profile for those individual chemicals, and how do those relate to the two mixtures that we're seeing. The biggest challenge in that is how to get a meaningful display when our data density is so low. So I don't have I don't have the numbers I'd like to see to make a really effective tool. I mean, it's there's about, I think, 10 or 20 mixtures that really have a good overlap between each other in terms of the active ingredients. There are multiple active ingredient formulations.
Okay, thank you. I don't see any more questions. And we'll maybe pause for a couple of seconds, maybe a minute or so, to just make sure there weren't any further questions.
Yeah, and
I have
will be
quick. Yeah, go ahead, Shannon.
Okay, so I will be attending the ASCCT annual meeting, and I would be happy to talk to folks there. We'll have more details on the current IVIV workflow, and I'll make sure to get some more details on the next module that will be coming out in the spring. So if folks wanted to follow up with some questions there, please send me an email, and I'll be happy to set some time to talk with you one-on-one and to walk through what I showed. And if you have ideas for features or data, please let me know.
Especially data.
Yep.
I was wondering if you collect user statistics.
We do collect some. I haven't looked at them. Normally after a presentation like this, the data usage or the amount of hits goes up quite dramatically. And then with each new release, we're expecting an increase in traffic with the addition of the online tools.
Great. All right. Well, I don't see any more questions coming through, so I really want to thank you for your time, for your presentation, and for all of the work that you and the ILS team has put into this tool. And thanks everyone for your attention, and I will say goodbye. Okay. Have a great afternoon.
Thank you, everybody.
Thank you. Bye-bye.